So this is the third state of matter, which we already know very well. So that is only we used to called as gaseous state. So if you all observe very carefully, first we studied the solid state and properties of solid state. Next one, liquid state and properties of liquid state. And now in our today's class, we are going to study gaseous state and properties of gaseous state. So we all know, of course, whenever I told you about the gas, so some substances will come into your mind. Immediately one point will remember in your mind. That is what particles are. Everybody, particles are
Very loosely packed.
very loosely
Loosely
packed.
packed.
Understand? And you all know gases we cannot keep it in open container because they're having a large force, large molecular for like what we can spaces, intermolecular spaces, and the least force of attractions. So that is what we can say. As soon as if you heard about gas, immediately we can say they are very loosely packed. Is it right or wrong, everybody? Loosely packed, and they are very easily we can see they are having a large intermolecular space of attraction, so they can proceed. They can easily go fast very easily from here and there. Is it yes or no, guys? All of you? Yes. And what about the force of attraction present between them? Is it very more or very less?
Very less, sir.
Yeah, that is what negligible force of attraction they have. So that is the reason they are very like kinetic energy is more, and they're having highest volatility. What do you mean by the volatility? We all know. Yesterday I had taught you. Volatility means what? Change in, all of you, easily change in state. Understanding? Easily change in state. So they are having highest volatility in nature. So they are called as gaseous state. So they are having more spaces between them and least force
Sir,
of
because gases have low density.
yes, of course. They are having low density, and you can notice it. These gases, they can easily move from one place to another place because of least force of attractions. So that is why they are called as, what is to call everybody? They is to called as gases. Is it clear, all of you? Understand or not? Yes, please.
Yes, sir.
Yeah, write it. Definition. Definition. The state of matter having the state of matter having loosely arranged particles, highest volatility, and negligible force of attraction, between the particles is called, what is to called, everybody? Is to called as, yes please, what is to call, Mr. Lingesh, Gokul Ras? Who is to called as gas? Is it okay, everybody? So those who are having a negligible force of attraction, highly volatile in nature, is called as gases. Okay, so just all of you read the definition of gas, all of you. Clear? So now, so with the help of this definition, let us analyze the properties. So that is what? Properties of gases. So all of you keep heading. Properties of gases. Now, let us go back to the solids and tell me. So we all studied that solids having definite shape and definite volume. Liquids, no definite shape, but they have a definite volume. But now coming to the gases. Now you tell
No
me,
definite shape and
is it they are
volume.
having a definite shape and definite volume? Anybody?
No, sir.
No.
No, sir.
That is the first property. So no definite shape. All of you write it. Because why no definite shape? Because particles are very loosely packed. The particles are very far each other. So that is why they do not have a fixed shape, as the particles are very, very far apart. That is the reason they're having negligible force of attraction. Understanding? And between the particles, they're having more intermolecular spaces or less intermolecular spaces in gases.
Less
Yes,
intermolecular spaces.
space Mari, gases is
Sir,
it
more intermolecular spaces.
more or less Mari, space
Ah,
and
yes,
More.
sir. More
space
intermolecular
is more.
spaces.
Understand? Not less. Force is negligible, and particles can move only in to and from motion, or randomly it can move in any direction. Everybody.
Randomly in any
In
direction.
any direction. And is it possible to store the gas in open surface? Everybody, like gases,
No,
like
sir.
solids and
No,
liquids?
No, sir.
No. So they do not have any open surface. So they can go in any direction. Always gases should be closed in what? Closed container. Understanding? So that is why we will say it is actually a no definite shape. We people cannot keep it in a open container. No open surface for it. Is it right or wrong? For example, if I take the solid is having all open surface. Yes or no, Mr. Lingesh? Everything is open surface, nothing problem. And liquid also we can keep it one side open. Yes or no? Everybody, Kishore, Agalya, understand? But gases, always there is no open surface. Always we have to place it in where? Always you have to place it in where, guys?
Closed container.
Closed container. Why we should place the closed container?
Because the molecules move away from the
larger
container.
molecular space, it will go here and there. All the particles will move randomly. That is the reason always we have to put it in a closed container. Sir, so can you tell me there is no definite shape? Then what is the example? Now, if I blow the air into the different balloons, you might be nose. So have you noticed that different balloons, which is inflated balloons, they are not having a same shape. They'll be having a different shape. Is it right or wrong? All of you understood? Clear or not? Please respond. Clear? That is what you
Yes,
have to
sir.
remember. So, different balloons have different shapes, because the air does not have any kind of shape, so they will be having a different shapes according to the type of the balloon. So that is what we can say that. So no definite shape, write it. The gases do not have fixed shape. The gases do not have fixed shape, as the particles are very close or very far. Everybody, very
Far.
far apart. Yeah, very far apart. Because why they are very far apart? Because what is the reason? Because negligible force of
Attraction between the
Very
particles.
good. Yeah, very good, Nivedan. A negligible force of attraction. Now, these particles can move in only one direction, or they can move in any direction. All of you. Particles
Any
can
direction.
move. But what about the liquids? Liquids particles can move where? Only within the liquid. Do you all remember that I have taught you? Yes or no? Particles of a liquid can move only within the liquid, but gases not within the gas. Anywhere they can go it. So that is why they can move in all the directions, because they do not have any what? Any open surface. So always we have to keep it in where, guys? We have to store, or we have to keep in which containers?
Closed container.
Closed containers. That is what you have to remember. So that is why we will say these do not have a fixed shape or definite shape. Is it okay, guys? Yes, please.
Yes,
Yes,
sir.
sir.
That is all. Okay. So please make it. Clear, Amma? Understood now? All of you? Yes?
Yes, sir.
Okay.
Yes,
Next.
sir.
They do not have any fixed shape also, and they do not have any fixed as well as what they are having. They do not have no
Volume.
fixed volume. Okay. So that is what you have to remember. For example, sir, how you can say no fixed volume? Now, do all people knows your LPG cylinder in our home? Everybody? All of you? So if you know that LPG cylinder, just check it, everybody. So we know that the weight of the LPG cylinder, they'll put around 19.2 kg. Is it right or wrong? Have you verified? Next time, if you see the cylinder, you can see that. They'll put 19.2 kg, of course, including the weight of the cylinder. Is it okay, Mari? Clear? Now,
Yes, sir.
the gas which is present inside this cylinder, all of you remember. Now, if I release it, is this gas will occupy whole our house? Is it right or wrong? Everybody? Yes? Sir,
Yes,
no.
sir.
Yeah. The same gas, the gas which is present inside the cylinder, if I release and if I provide a space even equals to this entire Pudukkottai district, the gas can be occupied. Understanding? So the same one gas cylinder, the gas even can occupy the space which is equals to entire Pudukkottai district. So means the same amount of gas, I can keep it in a big tank. That is also it can be filled. Fully it is occupied. If I kept it in a more bigger tank also, it will be occupied. So, but the amount of gas is same, but what is not same? The volume is not same. Is it right or wrong, guys? Yes?
Yes, sir.
Yeah. So that is what you have to remember it. Okay. So now Abhiram is asking an interesting question. Sir, if you blow an balloon and put an knot in it, and after 5-6 days, the balloon comes a little smaller. How it is possible, sir? All of you remember when we are tying and we are putting the knot, all of you remember, due to the atmospheric contact, directly every time the balloon is contacting with the air, the thickness of the balloon becomes very thinner in the sense of a weak zones will form. So wherever the weak zones are forming, through that, like a puncture, bicycle puncture, how it will be happening? So slightly the air will keep on decreasing. Of course, it won't be decreases fully. Very minutely it will be decreases. And as well as wherever we have been made a knot, through that process, at that place also, slowly some leakage will stop, some leakage will produce. Due to that, the minute holes, the volume of the balloon will be keep on decreases. Is it okay, everyone? Yes?
Yes, sir.
Yes. That is one. Okay, clear? Okay? So,
Yes,
right.
sir.
So no
Yes,
fixed
sir.
volume. No fixed volume. Right. The gases do not have fixed volume. Why, guys? Because the particles having high kinetic energy or low kinetic energy. Mr. Sam?
High kinetic energy.
High kinetic energy.
Kinetic energy.
They do not have any kind of a fixed volume. Okay, so no fixed volume. Particles can go anywhere and they can occupy whatever the space you provide, they will occupy it. Okay, so gases do not have fixed volume. Gases do not have fixed volume because Kishore, Purima Kishore, because the particles have high kinetic energy or low kinetic energy. Everyone, high
High
kinetic
kinetic energy.
energy. Okay.
High kinetic.
high kinetic energy and can move in all the directions. So that is why we have to always store in where?
Close the
Closed container.
Okay, that is what? All the directions. Therefore, they can occupy the given space. Therefore, they can occupy the given space. So till here you complete it. So two properties. Any doubt you can ask. Write it.
Sir, what is the third point?
Which one? Therefore, they
Therefore,
can occupy the given space. Whatever the space you give, it will occupy. Understand?
okay, sir.
Yeah. Completed? All of you?
Yes, sir.
Yeah.
Yes, sir.
Now, observe very carefully. Next property is again the similar thing what we are going to study just now, like a LPG cylinder in our home. Now, as I told you, LPG full form. Can anybody tell me what is the full form of LPG?
Liquefied petroleum gas.
Liquefied petroleum gas.
Liquefied petroleum gas. Same way, CNG. Can you tell me what is the CNG?
Compressed
Compressed
natural
natural
gas.
gas.
Natural gas.
Compressed natural gas. So you can see compressed natural gas and as well as LPG means liquefied petroleum gas. Actually, one cylinder of these gas or this gas, if I release, as I told you, it can occupy any volume of the space which is provided by me. But that much amount of gas, almost in a gas cylinder, 14 kgs of gas they have been stored. So that how it is possible to store? Is it possible to store that much huge amount of gas in a small area or small volume? Yes, it is possible.
Yes,
Why?
sir.
Because the gases are
Compressibility.
highly compressible in nature. Understanding? Not compressible, highly compressible. So due to that property only, we can see a huge amount of gas has been stored in a very, very small container. Do you all understand, all of you? Highly compressible in nature. Okay. So if you take this, why sir they are very, very highly compressible? Anybody can tell me? Because
Sir, the
wind,
particles are loosely
yes,
packed, sir. Very
the
loosely
particles are very, very loosely packed under the normal conditions. So they are very, very far apart from the normal conditions. So as I told you yesterday, nitrogen gas can be solidified, liquefied at what temperature of what temperature? Minus
packed.
minus 196 degrees
190.
Celsius. Understanding? So means at that temperature, it will turns into liquid state, means in the sense of the space between the particles is decreases or increases? The space between the particles decreases.
Decreases.
Right or wrong?
Decreases.
That is what. At minus 76 degrees Celsius, we people used to get minus 76 degrees Celsius, we people get dry ice. Dry ice in a sense of we all knows. What is that? Solid carbon dioxide. Sir, no. Solid carbon dioxide. CO2. Solid CO2 is to call dry ice. So means at that time, dry ice, distance between the particles is very close or very loosely packed. Everybody. Very, very closely
Very
packed.
close.
That is what. So because at the normal conditions, the distance between the particles is very, very far. So when we apply the pressure is applied, these particles, they will get accommodated in the gaps. Like the gaps between them is decreased. That is what it will happen. But if you want to compress the gas, we need very, 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 very high pressure to compress this gas. So you can see that LPG and CNG gas, which are kept at high pressure in the cylinders, extremely high. So when they are storing inside the cylinder, it is actually, they'll be compressed with extremely more and more and more pressure. Is it okay, guys? Everybody clear? Understand everybody?
Yes, sir.
Yes. So now
Yes,
let us
sir.
check LPG pressure. All of you notice it. The pressure is about, the pressure of a cylinder gas varies from 2 to 3 bars depending on the temperature. Okay. So, but when the cylinder is designing, you can see the operating pressure of the cylinders is almost designed for 17.5 bars. So what is the bar? Bar means what? Is the unit of what? All of you. Unit of pressure. Okay, Sanjay, clear? Nivedan? Please respond. So the cylinder is designed to be 17.5 bars. Okay, bar is the unit of pressure. Please remember that. So what is the unit? What is the unit for pressure? You know, people. Anybody can tell?
Basket.
Ah, yes, please. Pascal. Very good. So you all people knows Pascal. Do you know that 1 bar is equals to how many pascals? All people. So 1 bar is equals to 1 lakh pascals. Clear, Mari? So that much high pressure we are
Yes, sir.
having. Okay. The cylinder is
10,000.
highly compressed. So 1 bar is equals to 1 lakh pascals. Like 17.5 bars, the cylinder is designed almost for 17.5 bars. Okay. So bar is also one of the unit of what? Everybody. Unit of pressure.
That's good.
Okay, guys. Understood? Please respond.
Sir.
Yeah.
Yes, sir.
So that is what you have to remember it. Okay. So proceed now. So let us see all of you. So this is what it is. That is why LPG stands for liquefied petroleum gas and CNG stands for what? Compressed natural gas. So almost 17.5 bars pressure, we people are storing this gas inside the cylinders. So if you notice that liquefied petroleum gas means in the sense of, actually it is a gas, and when it is coming out from the cylinder also gas only. But if it is inside, what is the state of the gas? Liquid state or gaseous state? Inside the cylinder, liquefied petroleum gas. Yes, please. Liquefied petroleum gas means it is compressed. It is compressed into liquid state. Understand? So the gas is converted into liquid by applying pressure, more and more and more. Then only it will be converting into liquid state and it can be stored. So that is why generally the law that gases can be compressed by lowering the temperatures and as well as applying the pressure. Very, very important this. So when the pressure is released, again the gas changes into what? It will again back into what? The liquid will changes into everybody.
Gaseous.
Gaseous state. Under high pressure, it will be in liquid state. And if you turn the gas cylinder, that cylinder gas is coming liquid state or gaseous state in the burner. In the burner, what is coming? Everybody.
Gas.
In the
Gaseous.
burner, what you're getting, guys? Gas.
Gas.
Is it right or wrong? Everybody.
Yes, sir.
Yes. So
Sir.
that is what you have to remember. Is it okay, guys? All of you? Understand?
Yes, sir.
Yes,
Yes,
sir.
sir.
That is what. So how we can increase the pressure? By decreasing the temperature, we can compress it. By decreasing the temperature and by increasing the what? When pressure is increased and by lowering the temperature, we people can compress the gases more and more. So that is why the LPG which we are using as a domestic fuel, highly compressed gas, and CNG
Sir, one
also.
doubt, sir.
Yes, Mari.
Sir, LPG is in the liquid form, sir.
Inside cylinder.
When we are pressuring it, so that the temperature decreases, no, sir?
Yes, highly temperature decrease inside cylinder, Mari. See, inside cylinder, the gas is almost compressed at 17.5 bars. Understand, Mari? But
Yes, sir.
as soon as the gas is coming out from the knob. You understanding? Clear?
Yes,
So
sir.
the gas is operated at 1 to 2 bars. Do you understand, Mari? So at these cases, again the pressure is decreasing. Pressure is decreasing means also automatically the gas will be converting from liquid state to what state? gaseous state. Understand, Amari?
So when the pressure decreases,
Yeah, pressure decreases, again it will be gaseous state. At actually the low pressures, it will be in gas state. Understand, Amari?
yes,
So
sir.
because of compressing, I compressed by increasing the pressure. That is why it will turns into liquid state. So as soon as if I on the knob, again it will be low pressure. Low pressure it will create.
Then means when the pressure increases, temperature will also increases.
Of
No,
course,
sir?
but here what we are doing reverse. By lowering the, if you want to compress more, you have to decrease the temperature and increase the pressure. Puriyama Mari?
Yes, sir.
For compressing more, actually, you need to lower the temperature and increase the pressure. Is it okay, Mari?
Yes, sir.
That is
Lower
what
the
lower the temperature and increase the pressure. Okay. Then the compressibility nature will increases. Okay, everybody understood?
Yes, sir.
Okay. So write it. All of
sir,
you.
when we lower the temperature, it will change into gas, no, sir?
Yes, Mari. Suppose see now, I will change this into dry ice. Now, gas into gas, lower the temperature, not lower the pressure. Okay.
Yes.
Yeah, for example, see, you are having a gas, carbon dioxide. What is the pressure, for example? CO, dry ice, suppose if you take, normally carbon dioxide at normal room temperature. What is that state? Yes, please. What is the state of it? Respond.
Minus 70,
Minus?
76 degrees Celsius.
Not Mari. Normal room temperature, what is the state of carbon dioxide? That is what I am asking. It is a gaseous state. Yes or no?
Yes, sir.
Now I will reduce the temperature. Slowly I will reduce the temperature to minus 60, minus 70, like that. So at minus 76 degrees Celsius, it will turns into solid ice, solid CO2. So by the time, pressure is about almost 5.13 atms. But normally when the gas is at normal, what is atmospheric pressure? 1 atm. Understand, Mari? Normal atmospheric
Yes,
pressure
sir.
is 1 atm. At that 1 atm, what is the state of gas? Carbon dioxide. What is the state? Gaseous state. Clear? But if I increase
Yes,
the
sir.
pressure is increasing and temperature is decreasing. You see that it will convert into solid state. Have you understood?
Yes, sir.
Yeah. So
Sir.
as soon as again if I release, if I kept it in an open area, suppose I expose the dry ice into open area, then what will happen? The temperature is keep on increases. Yes or no?
Yes, sir.
So temperature increases means what will happen? It will converting into what?
Gaseous.
Gaseous state. That's all. Means it will come to the normal pressure. It will come to the normal pressure, so it will become into
Yes, sir.
gas. Clear? Understand, everybody?
Yes,
Sir,
sir.
one doubt.
Ask me English.
Sir, usually gases we compress means it is formed as a liquid only, no, sir?
Solid also will form. Sublimate products will turns into solid.
Yes, sir.
If you want to form the dry ice, you have to compress it. But you cannot get liquid carbon dioxide. You will get only solid carbon dioxide. Understand, Lingesh?
Yes, sir.
Suppose at minus 196 degrees, you will get a liquid nitrogen. Clear, Lingesh? Liquid nitrogen.
Yes.
If you are decreasing the temperature more further, we'll get a solid nitrogen. Clear?
Yes, sir.
Understand? So that is what you have to remember. Clear?
Yes, sir.
Yeah, that is what you have to remember. Make it. Okay? Understood?
Understood, sir.
Yeah, write it. Make it. Highly compressible. Gases are highly compressible. Gases are highly compressible. See, single property, this much time it will take. That is what you have to learn all the things. Clear, everybody? Any doubt, anyone can ask me, please. Okay, guys? Yes.
Sir.
Gases do not, sorry. Gases are highly compressible because, what is the reason? All of you. Because the particles are what? Very close or very far? Very far apart from each other. At what temperature? At normal conditions. Understand, everybody? under normal conditions. So normal conditions means what? At room temperature and atmospheric pressure. Is it okay, Sanjay? Lingesh? Normal conditions means room temperature and room atmospheric pressure. Now, when the
Yes.
pressure is applied, when the pressure is applied, so what will happen? The particles get accommodated in the gaps. Is it okay, guys? All of you? These particles accommodated in these gaps, so that the volume is decreases or increases. Everybody, the volume is decreases or increases. All of you.
Volume
Decreases or
decreases, sir.
increases, sir? Decreases.
Decreases.
Compressing, decreases. So high pressure is required to compress a gas. High pressure is required to compress a gas. Pranav, understand? So how we can compress a gas? All of you. Generally, what is the law? We can compress a gas. General law is that we can compress the gas. How, guys? Gases can be compressed by lowering the what? Everybody. Compressed by, respond, lowering the temperature and applying what?
More pressure.
Applying
Pressure.
pressure or
Pressure.
more pressure. That is what you have to remember. Okay, guys. Clear?
Sir, then it will change into solid, no, sir?
No, liquid also, gas also. Some will be like sublimate products directly solid. Some will be liquid.
Yes, sir.
Understand, Mari?
Yes, sir.
That is what.
So one doubt, sir.
Yeah.
Sir, when liquefied petroleum gas is there, no, sir?
Yeah.
It's in the liquid state, sir. When we are increasing the pressure, the
Yes.
temperature decreases, no, sir?
No. When we are increasing the pressure, temperature won't be decreases, Mari. We are compressing by decreasing the temperature and increasing the pressure. Do you understand?
Yes, sir.
Then only we can highly compressible. Okay. Because
Yes, sir.
why means, listen, if I decrease the temperature, kinetic energy of the particles decreases or increases?
Sir?
If I decrease the temperature, kinetic energy of the particle decreases or increases?
Decreases.
Decreases, sir.
Understanding, so that we
Decreases.
can compress more. Understand, Mr. Lingesh? That is the reason. Clear?
Yes.
For
Yes,
example,
sir.
if you want to compress a gas which is at extremely high temperature, so you need to apply more and more and more pressure. Is it right or wrong? Because particles are having more kinetic energy. So it is very, very difficult to compress. Is it clear, everybody? Understand?
Yes,
But
sir.
if I reduce the temperature, what will happen? Kinetic energy of the particles is decreases, so that I can easily compress it. Is it yes or no?
Yes, sir.
Yes,
Sir,
That is the
then
meaning of I am saying. Are
there
you
will
clear
be
now?
any change of status, sir?
Yes.
There will be any change of status, sir?
There will be a change of state means now if I highly compress the liquid, that LPG gas, it will come to liquid state. So inside the cylinder actually it is in liquid state. Understand?
Yes, sir. Sir, then
If I on
when
the
you
knob,
come
listen, if I on the knob, this gas, actually that knob is having low pressure than cylinder. Understand?
Yes, sir.
So the pipe which is carrying the gas into the gas stove is having a low pressure. So at low pressure, what is the state? Actually, here is the cylinder and here is the connecting now. So connecting that. Now from here, the pipe, the gas is enters. Here extremely high pressure and here low pressure. So if it is a low pressure means immediately it will turns into what? Gas. Clear?
Yes,
Understand,
sir.
Mari? That is what it will happen. Clear?
Yes, sir.
Yeah. Because low pressure, it will be converting into gaseous state. Okay, guys? All
Yes,
of
sir.
you? Yeah.
Sir.
Now for this one,
Yes, sir.
group activity, you can take LPG and LPG gas and CNG gas, and they have given one activity in our book also. That is what this activity. I think activity this is. Take 100 ml of syringes and close their nozzles by rubber corks as shown in the figure like this. Okay. Now they are asking us, remove the pistons from all the 3 syringes and leaving one syringe untouched. Fill water in the second and pieces of chalk in the third. Okay. Clear, everybody? So leaving one syringe untouched. Untouched means it will fill with something. Can you tell me it is filled with what? Air. Yes or no? Yes or no, guys? And the second cylinder we have to fill with water, and third cylinder we have to fill with what? Chalk. Now insert the pistons back into the syringes, and you may apply some Vaseline on the pistons before inserting them into the syringes for their smooth movement. Smooth movement, that is what, like a lubrication. Understand, Sivani, Agalya? We have to apply some Vaseline so that piston can move very easily. Now try to compress the content by pushing the piston in each syringe. So in which syringe we can easily we can press the piston. Everybody, you can see that.
Yes.
Yes.
Understanding? Gas piston. So almost. But is it further possible to compress, Mari? We cannot. Understanding? Because it is that empty space is filled with what? Actually, when I remove the piston, the air will go inside. Yes or no, Mr. Pranav? So that can
Yes,
be
sir.
compressed. So if I remove the piston, the same air will occupy full syringe. If I press the piston, the same air will be compressed very smaller area. But liquids, you cannot. Understanding? And gases also, sorry, solids also we people cannot be. So if I press that with a syringe with a chalk piece, is it possible to press it, everybody?
No, sir.
No.
No, sir.
Understanding? And liquids, water is also, is it possible to compress? All of you?
Sir.
No. Somehow, somewhat we can compress it. Understanding? But who can compress it highly? Everybody. Who can be
Gases.
Gas.
gases? So I can make a conclusion here. The compressibility decreases from gases to liquids and liquids to solids. Is it right or wrong, everybody? What is the reason behind? The distance between the particles. Is it right or wrong, everybody? Do you all accept it or not?
Sir.
Yes,
sir.
that is what you have to remember. Understood, everybody? So I will write it. Compressibility is decreasing from where to where? Compressibility is decreases from
Different state to
decreases
state.
from gases to
Gas.
liquids. Understanding? So compressibility decreases from gases to liquids. Liquids to what? Gases.
Solid.
Yeah, solids. Okay. So sorry, I have written wrong. Solids to liquids, liquids to gases. So who can be having highly compressible? Highly
Yes.
compressible gas. Compared to gas, liquids are little less. And solids very, very less. Not at all possible to compress. Almost remember, solids and liquids cannot be compressed. Okay, guys? Understood, Amma? Generally, that is what you have to remember. Because from solids to gases, particles